Hi, welcome to the Space Nook. I'm Amber, and here we talk about really cool space stuff, and then I give you a book recommendation so you can learn even more things. Today we're going to talk about Mars colonization, which is a pretty hot topic in the media, and all of the challenges that humans are going to have to overcome in order to create a successful Mars colony. We're only going to touch on 4 things, but there's like a million. So if you like this video, like and subscribe, follow me on Instagram, and we can do more of these things. The colonization of Mars has been a popular topic for decades. We humans recognize our own demise, and we see that we probably won't be sticking around on Earth forever. There's no doubt that humans as a species face significant challenges for our own survival on Earth, and it's not a question of if, but when a major catastrophe will hit us. So, the smart move seems to be expanding our species to other worlds, and Mars looks promising. Mars is ideal for our first go at settlement on another world. It's got a surface area similar to Earth's dry land and about 1/3 the gravity of Earth. Plus, there are signs of useful materials and even water below the surface. But Mars is still a volatile planet and throws a lot of challenges at us, physical, technological, and ethical. Here are 4 challenges humans will need to overcome before settling on Mars. Challenge 1: breathing. You can't just go for a walk on Olympus Mons and take a deep breath of Martian atmosphere because you will suffocate. The atmosphere of Mars is much thinner than on Earth's, and it's made of 95% carbon dioxide and less than 1% oxygen. Scientists have some ideas to overcome the whole breathing thing, like making machines to turn Martian air into oxygen. Perseverance carried a small experiment to Mars called MOXIE, which was about the size of a microwave. MOXIE worked like a tree, taking in carbon dioxide from the Martian atmosphere and releasing oxygen. This technology would be crucial for astronauts who will need oxygen both for breathing and for fuel. MOXIE's mission is now finished, and it produced a total of 122 grams of oxygen. That's about what a small dog can breathe in 10 hours. Challenge 2: radiation. Mars not only lacks a thick atmosphere, it lacks a single unified global magnetic field like Earth's. Instead, it has weak, fractured magnetic field remnants in certain regions of its surface that have different intensities and polarities. Here on Earth, we have a magnetic field that shields us from radiation. But on Mars, you have to worry about 2 sources of radiation. First, solar radiation from the sun. The sun releases a steady stream of particles and occasional larger bursts during its peak activity called coronal mass ejections. These particles, mostly protons, can be blocked, but they're still a concern. The second source is galactic cosmic rays, and they're harder to shield. Galactic cosmic rays are super energetic particles traveling close to the speed of light from other stars in the Milky Way or even other galaxies. Like solar particles, galactic cosmic rays are mostly protons. However, some of them are heavier elements. These heavier elements can collide with materials and knock out atoms in structures, spacecrafts, and even astronauts, causing serious damage. Scientists are working on ways to protect astronauts and spacecraft from this radiation, but it's not easy or cheap to shield astronauts through pure bulk. One idea is using special materials like hydrogenated boron nitride nanotubes. These are tiny tubes made of carbon, boron, nitrogen, and a little bit of hydrogen mixed in. And they're really good at absorbing radiation and could probably provide pretty good protection. Another idea is to create literal force fields. Yes. This force field would be similar to Earth's magnetic field and would be a relatively small, localized electric or magnetic field, which would create a protective bubble around spacecraft or habitats. There are also operational strategies to reduce the risk, having a safe area on the spacecraft for radiation storms, minimizing time spent outside shielded areas, and even medication to counteract some or even all of the health effects caused by radiation exposure. Challenge 3: babies. In order to propagate a species, you're gonna have to have kids, but off-Earth babies are gonna be tricky. The female body is typically more vulnerable to radiation and has an increased risk of cancer, especially in the reproductive organs. Scientists are studying this issue closely, like with the recent experiment involving two mannequins named Helga and Zohar aboard Artemis 1. These mannequins actually simulated female bodies and endured the radiation dose of a lunar flyby. To understand the effects of radiation on the female body better, researchers placed tiny crystals in the mannequins' bodies, which simulated sensitive body parts like the lungs, stomach, uterus, and bone marrow. The data hasn't been released yet, but scientists are working on it. I'm really looking forward to what they find, and I'll do a video on it in the future. Okay, but if women can't safely have babies on Mars, what are we gonna do? There are some ideas like building artificial wombs or even genetically engineering offspring to better survive in these harsh environments. But these solutions raise big ethical questions like, what if we messed up the genetic engineering or the artificial womb babies can't survive? What rights do these Mars-born babies have if they wanted to return to Earth? Challenge 4. Legal considerations. Who makes the rules on Mars? Do Earth laws apply to Mars colonists? There's a document called the Outer Space Treaty that was originally motivated by concerns over the use of nuclear weapons in space and now governs how nations act in space. I've included links to the Outer Space Treaty and other space agreements in the description below. Living together on Mars might be simple at first if people share the same beliefs and values. But as more people join and they bring different customs and beliefs, it could get complicated. Figuring out a set of rules everyone agrees on can be tough, especially as the colony grows and becomes more diverse. They would need their own Mars Constitution, like a Mars-titution. People are also debating how to ensure human rights. The first people to go to Mars will likely not be able to return to Earth. It's a one-way trip. Despite knowing this, future Martian pioneers are excited and willing to give up things like choosing where to live or receiving medical care, all for the chance to explore Mars. The success of the mission will depend on how well everyone can work together in such a challenging environment. This might mean making decisions for the good of the group, even if it's against what individuals want. Spending a long time in space can take a toll on someone's physical and mental health. Being isolated from others and living in a confined space can cause psychiatric distress and make people act differently. So tough choices will need to be made, like deciding what to do if someone becomes seriously ill or if someone needs to sacrifice themselves for the sake of the colony. These challenges barely scratch the surface on what humanity needs to figure out before settling Mars. Here's a book recommendation. There are plenty of books that dive into the challenges of living on Mars, but one of my favorites is The Next 500 Years by Christopher Mason. He starts with outlining the twin experiment with astronauts Scott and Mark Kelly, which is crazy if you haven't heard of it. And then he lays out a 500-year plan for the huge project of re-engineering human genetics to adapt to life on other worlds. Thanks for tuning in to my very first YouTube video. Let me know what space subject you want to learn about next. One idea is using special materials like hydrogenated boron nitride tubes, nanotubes. Hydrogenated boron nitride nanotubes. Hydrogenated